So this is a short video in which we are revising integration for IB, Math, AASL. Introduction to integration is anti-differentiation. Correct? So it's an anti-differentiation, you should know that. Correct?
Yeah.
Fine. Anti-differentiation with boundary condition to determine the constant term. So if you have your derivative, like we can do this example itself. So, and y is equal to 10 when x is equal to 1. So dy by dx has been given. And y is equal to 10 when x is equal to 1. Then you have to find this. Then they'll say find y. So what you need to do is your y will be the integral of dy by dx. Remember that.
Yeah.
So y is equal to integral of dy by dx. So when you take the integral of 3x square plus x dx.
X.
So this will be 3x cube over 3 because integral of x raised to n is what? X raised to n plus 1 over n plus 1. Correct? Plus c. Plus c. Okay. So plus, what will this be?
X square over
X square over 2. I don't know why this is happening. Plus c. This and this cancels. Now use the boundary condition. What is the boundary condition? You have to find c. So y is equal to 10 when x is equal to 1. So 1 cube plus 1 over 2 plus c. So if you solve this, you'll get your c as 8.5.
Yeah.
Put it back in this. And then you get your answer like this.
Yeah.
The answer won't be given here. They're just saying that.
Yeah.
Put it back and you'll get the same form. Definite integral using technology. Area of the region enclosed by y is equal to fx and the x-axis when fx is greater than 0. So basically what's going to happen is if you have a function which is greater than 0, okay, this is let's say a, b, then the area between the curve and the x-axis.
F of B.
So area is equal
Integral
to
of A and
B
and then brackets
function. If fx is greater than 0.
Yeah.
Student expected to write the correct expression. This is very important before calculating the area. It's very important in your paper you write this expression like this, putting the limits like this. For example, like this, lower limit, upper limit, function, and this.
Yeah.
Okay, fine. Develop the concept. That's fine. That won't come in the paper. This is for teachers basically. Derivatives we have done in the earlier video. This we have done. We have done all this we have done. I'm looking at integration in this video. Kinematics. Now kinematics, you need to remember one thing. So you have your displacement, you have your velocity, and you have the acceleration. When you differentiate displacement, you will get velocity. When you differentiate velocity, acceleration. When you integrate
velocity, you get displacement.
Correct.
When you integrate mod of velocity, you get distance.
Correct.
The distance can't be negative.
But one thing is very important. Your displacement.
Yeah.
Displacement can be positive, it can be 0, it can be negative. What does displacement positive mean? The body is on the right or above the origin. What does displacement 0 mean? It's at the origin. Negative mean it's on the left of the origin.
Yeah.
What does velocity positive mean?
On the right.
No, moving to the right. Remember, displacement gives us the position. This gives it a direction, velocity. So velocity being positive means it's moving to the right, or it's moving down. No, moving up. Sorry, beg your pardon. If it's negative, then what? It's moving to the left. Moving to the left. Correct? If it's 0, what does it mean?
I'm moving towards.
0, velocity being 0.
Oh, then it's changing the direction.
Very good. It's changing direction. Very, very important. When the velocity is 0, the body changes direction. This is what they keep on asking. So when the velocity is 0, the body is changing direction. Correct? Or it has the rest. The two of the interpretation. Or the body is at rest. Okay. Acceleration. When is acceleration positive?
It's moving to the left.
Acceleration positive means what? Means the velocity of the body is increasing. It means that the velocity of the body is increasing. correct? Or the speed is increasing, to be precise, actually. Okay. When is your what if it's negative? Velocity increasing. Take vector with vector, and your velocity is what? Decreasing. If it's negative, acceleration is negative, velocity is decreasing. If acceleration is zero, means what?
Then velocity.
Uniform velocity. There is no change in the velocity.
Constant.
Constant. The velocity is constant. Okay, now about speed. When will speed increase?
Acceleration.
Speed increases when velocity is positive and acceleration is positive, or when velocity is negative and acceleration is negative. Both should have the same sign, because this vector should be directed in the same direction. Achha, when will the speed be decreasing?
When the signs are different.
Opposite, yeah. When velocity is positive, acceleration is negative, and when velocity is positive and acceleration is, opposite side.
Yeah.
Velocity negative, positive, positive, negative. Yeah. So please remember that, and this is important. And obviously, you draw the sign diagram for all this. You draw the sign diagram for all this to realize it. Now, the next thing you need to remember that your displacement is the integral of the velocity. Definite integral of the velocity.
Yeah.
Your distance, now this is displacement. Distance cannot be negative. So it's the absolute value of the velocity and you integrate them.
Yeah.
For this you have to use GDC always.
Yeah.
This one always you have to use GDC. Speed is the magnitude of velocity. Therefore you take the absolute value. Now, indefinite integral. These are there in your formula booklet. So integral of x raised to n is x raised to n plus 1 over n plus 1. Correct? We'll see this in the formula booklet. Now what?
Integration of 1 over x is ln x plus.
Yeah. Correct?
Yeah.
So let me write it here only. So integral of x raised to n is what?
X raised to n plus 1 over n plus.
Integral of sin x is?
Minus cos n.
Minus cos x plus c. Integral of cos x is?
Sin x plus c.
Integral of 1 over x?
ln mod x plus c.
ln mod x plus c. Integral of e raised to x?
E raised to x plus c.
E raised to x plus c. Now, composite of any of these with a linear function. So basically, an extension of this would be, if you have integral of ax plus b raised to n, what will it be? Ax plus b raised to n plus 1 over n plus 1, you have to divide by the coefficient of x.
Divide by the coefficient.
Divide by the coefficient of x.
So
Reverse of the chain rule.
1 upon a.
1 upon
into
yeah,
this.
yeah. So 1 upon in the denominator.
Yeah.
Similarly, if you have integral of sine ax plus b will be what?
1 upon a into cos ax plus b.
1 upon a cos ax plus
minus.
b plus c. Integral of cos ax plus b will be
1
similarly
upon a into sin ax plus
1
plus
upon a sin ax plus b. So to always divide by the coefficient of x. Don't forget. 1 upon ax plus b. What will it be? 1 upon a ln ax plus b plus c. What is the integral of ax plus b?
1 upon a into e raised to
1 upon a.
plus c.
Correct? So that's your this part.
Okay.
Yeah. Integration by inspection, reverse chain rule, or by substitution in the expression.
That we did yesterday.
Yeah, that we did yesterday. So you do substitution. It's better to do substitution. So generally when you have this, you substitute this. You call this as u. So x square plus 1 is equal to u.
Yeah.
So you take the derivative du by dx. Make dx the subject. So dx is equal to du upon 2x. Substitute that. So that's your 2x. This is u raised to 4. Correct? This is your u raised to 4. Your dx is equal to du by 2x. This and this cancels. So this is u raised to 5 upon 5 plus c. Resum. So that's your x square plus 1 raised to 5 upon 5 plus c.
Yeah.
Similarly, here what will you assume? Or here what will you substitute in the second one? This one?
Sin x.
No. X square.
Oh.
You will substitute x square.
Yeah.
In this one, what will you substitute? Denominator.
No, always no.
Acha, now whenever you have e raised to sin x cos x, what will you substitute? Whatever e is raised to.
Yeah. So 1 upon sine.
Correct? Yeah. So you assume sin x is equal to u.
Okay, like that.
Assume sin x is equal to u in such things. Acha, whenever ln
You
is,
can't solve it without doing substitution.
you cannot solve it without doing substitution. Suppose you have like this. Whenever ln is there, you substitute 2x plus 1.
Yeah. Yeah.
You understanding what I'm trying to say?
Yeah.
So generally in the higher power, generally I'm saying, okay? Generally this, generally denominator, whatever e is very simple and ln is very simple.
Yeah. And if there's a root, then
Yeah. So inside the root there.
inside the root. Yeah.
Now, definite integral basically what you need to do in definite integral is when you integrate, you find out the integral. So in this case, your integral would be gx because your derivative and integral will cancel out. B and A.
So
Then you
g minus
do,
g.
upper limit minus the lower limit.
Yeah.
The value of the sum of the definite integral can be found by using technology. Just type it in straight. Area of the region enclosed by a curve fx and the x-axis, and where fx can be positive or negative without the use of technology. This is very, very important. So what will you do is, suppose you have a curve which is negative and positive like this, and you want to find the area under the curve.
So from 0 to the x was the axis.
Yes. So what will you do is, you will find out the x-intercept. Suppose a, b. You want to find till b. This is the x-axis. This is my function fx, and you want to find this area. So you first integrate. So your a1 will be area from 0 to a, fx dx, and your answer will come minus a, let's say, minus b or minus c, let's say. So minus, what will you do? So this will come, let's say, minus a1. Let's call this as area. So remember, when it's below the x-axis, your answer will come negative. Whenever the area is below the x-axis, the area will come negative.
Yeah.
Remember this. Okay. Now, what is the area? The second area be? You take it from a to b. Fx dx. That area, you'll obviously integrate it, put the upper limit, put the lower limit. That area will come positive. Correct? So therefore the total area would be what? Total area will be what? You drop the sign basically.
Yeah.
Are you following what I'm trying to do?
Yeah.
So you need to remember, if the curve is below the x-axis, then the area will come negative. So the area of this would be negative. The area of this would be what? Positive. So if you want a total area, you don't take the minus sign. You take a1 plus a2. That's the meaning of modulus.
Oh, you do mod. Area can be negative.
Area can be negative.
Yeah.
But if you want the integral, then you do minus. If they ask you what is the integral, you take minus a1 plus a2. Integral can be negative, but the area can be negative. So fx is positive negative without the use of technology. Area between the curves. How do you find out area between two curves? Now this is also very important. So suppose if you have two curves intersecting, let's say fx gx. How do you find the area between two curves? By hand. How do you find the area between two curves? By hand. Tell me, you remember the steps? Now remember, the area between two curves can be below the x-axis or above the x-axis. That won't matter. Your method remains the same. First step is find the points of intersection. Find the points of intersection. How do you find the points of intersection? You solve fx is equal to gx. You equate the two functions, solve fx is equal to gx. So you'll get, let's say, x is equal to a or x is equal to b. They're intersecting at 2 points. So this point gives you a, this point gives you b. First step is do that. Second step, Second step, what is the area between the two curves? You integrate from a to b, upper function minus the lower function. So upper function is the one which is above.
So
Hey, this is your g of x.
yes, sorry.
G of x is above. Upper function minus the lower function dx. If you switch your upper and lower, your answer will come negative. So you should realize you made a mistake.
Yeah.
So be careful of
You
that.
can just
Yeah.
do it again.
You do it again or just change a sign. Put a minus sign outside, just change the sign. This is very important. Now, in this part, it doesn't matter whether this is going below the x-axis or above the x-axis. See? So don't worry about that. That is only when you're taking with respect to the x-axis, not when you're taking between two curves. That's important. Sometimes children get confused with this.
Yeah.
So this is your definite integral. Now all that's it, and that's your integration.
This is all nature.
This is all HR, which you don't have to worry.